Hi, let's have a look about the introduction of spectroscopy. Let's start with the question, what is spectroscopy? Spectroscopy is the study of interaction of matter with the electromagnetic radiation. The matter includes the atoms, molecules, and any substance. It's an analytical technique used for analyzing the structural properties of the sample. We know that the atoms and molecules are infinitesimally small in size, so it's not possible to see them. All informations about atoms and molecules are obtained directly or indirectly from the spectroscopy. Here, the electromagnetic radiations are used to interact with the sample. The electromagnetic radiations have both electrical and magnetic properties. They show both particle nature and wave nature. These light waves are accompanied by different parameters. The first one is wavelength. Wavelength is a distance between the two adjacent waves and notated as lambda. And there is another parameter known as frequency, is the number of waves per unit time and is expressed by the letter nu. When an electromagnetic radiation is incident to a particle, some changes occur. The interaction of electromagnetic radiations with the atoms or molecules gives the spectra. By the nature of interaction, the spectrum can be divided into absorption spectra and emission spectra. This can be explained in terms of energy levels in the atom. When electrons from the ground state level absorbs energy from the electromagnetic radiation, it gets jumps into the high energy level called excited state. The spectra obtained by the absorption is called absorption spectra, which consists of dark lines. Next, the part is emission spectra. When the atoms or molecules present in the matter jumps from the excited to the ground state by emitting the radiation, this is called emission, and the spectrum obtained by the emission is called emission spectra, and it is made up of bright lines. Atoms interact with the electromagnetic radiation to give atomic spectra, and the atomic spectra consists of lines, so it is called line spectra. Similarly, molecules interact with the electromagnetic radiation to give the molecular spectra. The resulting spectrum is a typical band spectrum. Why these spectroscopic methods are widely used today? Because they require very less time for analysis and the less sample quantity is required. They give accurate results and the sample materials remain unchanged during analysis and can be reused. Spectroscopic techniques have been applied virtually in all fields of science and technology. Radio frequency spectroscopy of nuclei in a magnetic field has been employed in medical imaging technique called magnetic resonance imaging to visualize the internal soft tissue of the body with unprecedented resolution. Hope you all understand this session. Thank you for today.